Hello students, you are welcome back to another section with Prepclass tutors. My name still remains Mr. Shima, your tutor on chemistry. I'm looking at questions number 11 to 15. 11, 12, 13, 14, 15. Last time we looked at questions questions 6 to 10. So today we'll be looking at 11 to 15. So first and foremost, do not forget to always try to like all our videos, subscribe to our YouTube channel, and like our videos, as we will and always be bringing you with very fantastic and educational videos. So now let us start with our WAEC questions 2020 chemistry from questions number 11 to 15. Question number 11. The most suitable process of obtaining water from an aqueous solution of sugar is... The most suitable process of obtaining water from an aqueous solution of sugar is... They give you the first option here, crystallization. You can see the second option, distillation. You can see the third option, filtration. You can see the fourth option, decantation. So which one do you think will be the best option for obtaining obtaining water from an aqueous solution of sugar? Now, if you use the method of crystallization, you may be able to recover some sugar, but this will only help you to recover sugar, solid sugar, from the water. But they're asking you the most suitable method to remove at least this method they're asking you here. They want you to give us, or to give them, the best method of producing pure water from an aqueous solution of sugar. Now, let us see, how will we go about that? Now, if you look at crystallization, like I said before, that crystallization will only help you to get out some of the sugar crystals from the aqueous solution of sugar. Distillation is only used to separate a liquid from how will I put it now? When you have let's say a mixture of water and sand, an insoluble solid from a liquid, that is for decantation. Sorry, I'm saying distillation. Decantation, that's option D. Decantation will be used to separate an insoluble solid from a liquid, like sand from water. Filtration, the same thing. Is used to separate an insoluble solid from a liquid, let's say dust particle from water, whether you use a sieve. But in distillation process, you need to boil this aqueous solution over a temperature range. When it gets to that boiling point of water, what happens? Water will vaporize out. I should have shown you maybe a kind of diagram for distillation, but I was not provided with that. Water will kind of vaporize out of the solution. So for distillation, when you boil the water vaporizes out. The water vapor that comes out of the solution is then cooled to give you pure plain water. So distillation is mostly used in producing water, and is used in distillers and even brewery countries to produce the purest form of water. So the best answer here is distillation. Question number 12. Group 7 elements in their combined states are called is it halogens? Is it anions? Is it halides? Is it cations? This question looks kind of a bit tricky. Now, look at what are group 7 elements. They include fluorine, which is at the top of that group, chlorine, bromine, iodine, and one other element we call astatine. They are the group 7 elements. These group 7 elements are known as halogens. When they are in their free or combined states, we call them halogens. Halogens simply means salt formers. But when these halogens are in combination with another element, we call that compound a halide, most especially hydrogen. You can see here example I give here, hydrogen plus fluorine. This hydrogen fluoride. hydrogen and chlorine, hydrogen chloride, hydrogen and bromine, hydrogen bromide. In this form, we call them what? Halides. So when they say that group 7 elements in their combined states are called, I think the best option there is what? Halides. If you see there, you see halogens, you see anions, you see halides, you see cations. The best choice there is what? Halides. I believe you understand why it is halides. Okay, let's look at the next question. Number 13. When an ionic bond is broken, bonding electrons are, when an ionic bond is broken, bonding electrons are, this one too is another kind of a tricky question. Are bonding electrons shared? Are bonding electrons gained by the most electropositive atom? Are bonding electrons gained by the most electronegative atom? Or are they lost by both participating atoms? Now you must know that ionic bonding is just like electrovalent bonding. Let's say the combination between an element like sodium and chlorine. We call it electrovalent bonding or ionic bonding. So when you break that kind of bond, you will expect that electrons will be donated to the what? More electronegative atom. Electron will be donated to the more electronegative or the most electronegative atom. Remember that anions or negatively charged atoms or ions accept electrons, while the positively charged one donates them. So when the positively charged one donates the electron, the negatively charged one will accept it. So the best choice is that electrons are gained by the most electronegative element, and that is option C. I believe you understand why the best choice is option C. Question number 14. The oxidation state of chlorine in NaClO3 is, the oxidation state of chlorine in NaClO3 is. Now remember that the total oxidation state of a compound, of a neutral compound, is what? 0. So that was why I wrote NaClO3 equals 0. So the total oxidation state, if you sum up all the oxidation state of each of the elements here, it will give you what? 0. Now sodium is +1 because it belongs to group 1. Chlorine, though in most compound is -1, but in this compound it is not. But so since they are asking us to look for the oxidation state of chlorine, chlorine will be what? Unknown. That was why I put a question mark here. Oxygen, remember that oxygen has an oxidation state of -2 in every compound except in peroxide where it is -1. Oxygen has an oxidation state of -2 in every compound except in peroxide where it is -1. So you now say NaClO3 equals 0. So what is Na? Sodium, which is what? 1 plus chlorine. Sodium is 1, sorry for that, plus chlorine, that is Cl, then plus oxygen, which is 3 times the oxidation state of oxygen, which is -2. You bring it here -2, everything must equate 0. So you now have 1 plus Cl plus times minus will give you minus, 3 times 2 will give me 6 equals 0. And you have 1 minus 6, 1 minus 6, and that should give you -5. So -5 plus Cl will give you 0. So you take -5 to this side and Cl equals +5. Remember that when a negative sign crosses equality, it becomes positive. So Cl now equals +5. So the oxidation state of chlorine in that compound is +5. So +5 is the best choice. Quickly, let us look at the last question for today, which is question number 15. A balanced chemical equation is based on the law of, is it periodicity? Is it constant composition? Is it multiple proportion? Is it conservation of mass? A balanced chemical equation. Now, let us go back and look at what this statement tells us. For periodicity simply tells you that the chemical formula, the chemical nature of elements in a periodic table are periodic function of their atomic numbers. That is, in a nutshell, that each of the elements in a periodic table is arranged according to the atomic numbers. That is the law for periodicity. Law of constant composition is the same thing as law of definite proportion. And it says that what? All pure samples of a particular chemical compound contain similar elements which are combined in the same proportion by mass. Now, the law of multi-proportion, it just tells us that when two elements A and B combine to form more than one chemical compound, the various masses of one of the elements A, which combine separately with the fixed mass of the other element B, are in simple multiple ratio. Law of multiplication just tells us that when most elements react or combine, they do so in simple multiple ratio. Now, law of conservation of mass. It simply says that what? Matter can neither be created nor be destroyed, but can be converted from one form to another. Now, let us use an example of a balanced chemical equation. Then we can know in which of these statements, which one will go for a balanced chemical equation. Let's look at this one. Look at this equation. C2H2, that is ethyne. Ethyne is undergoing combustion with oxygen to give carbon dioxide and steam or water. Now, if you see here, this is a balanced chemical equation. Carbon here is what? 2 times 2, that is 4. Hydrogen here is 2 times 2, that is 4. Oxygen here is 2 times 5, that is 10. That's in the left hand side. Carbon is 4, hydrogen is 4, oxygen is 10. Look at in the right hand side, that is in the reactor, in the product part. Carbon here is 4. This 4 here is for both carbon and oxygen. Carbon is 4. Oxygen is 2 times 4, that is 8, plus this 2 here. This 2 is for both hydrogen and oxygen. So 2 times 4 is 8, 8 plus 2 is 10, oxygen is 10, and hydrogen is 2 times 2, 4. So the equation is balanced. Now, a balanced chemical equation must tell you that the number of atoms of elements in the reactant side must be equal to the number of atoms of elements in the product side. That now tells you that what? Matter can neither be created nor be destroyed, but can be converted from one form to another. So since each of these elements, as you see them, there is no shortage of atoms, it simply tells you that what? Matter or element or the compounds here, we are not destroyed, because carbon is 4 here, 4 here, hydrogen is 4 here, 4 here, oxygen is 10 here, 10 here. It tells you that the compounds or the matter or the elements, we are not destroyed. Then we are only converted from one form to another. Ethene was converted ethyne was converted as it undergoes combustion toward carbon dioxide, and the oxygen was converted towards steam or water. So that tells you that a balanced chemical equation must go or tells us the law of conservation of mass. So it's used to illustrate the law of conservation of mass, that matter can neither be created nor be destroyed, but can be converted from this form to another. So the best choice there is conservation of mass. Conservation of mass. So students, I believe you find these 5 questions we just did very interesting, very engaging, and very entertaining. So always remember to subscribe to our YouTube channel, like us on our YouTube channel, and you can always join us on WhatsApp for more educating and interesting videos on not only chemistry, but on every other subject which you find interesting in learning. So till we meet again, I still remain Mr. Chima, your prep class tutor on chemistry. Bye and have a lovely day ahead. Cheers.